Hello everyone, welcome to this problem where we are going to dive into shortest subarray to be removed to make the array sort. So you receive as input an array and you're supposed to remove a subarray from that array in such a way that the remaining array will be sort. Let me take you an example. If I receive this as input, right? If I remove from 10 to the end, I will have the rest of the array, which is 1, 2, 3, being sort, right? So in this case, the answer is 5 because I'm removing 5 elements. But is there any subarray that I can remove shorter than this that will also keep the array being sort? Yes, it is possible. If I remove from 10 to 2, I will have the rest of the array being 1, 2, 3, 3, 5, which is sort. So in this case, there's actually no subarray shorter than 3 that you can remove to keep the rest being sort. There are other alternatives of 3, which is actually this 3, 10, 4 that will leave you with a sort array. Okay, so the problem is actually easy to understand, but now how do we approach this? How do we even solve this type of problem? So for me to solve this problem, I'm going to use the two-pointer approach, and the idea will be as follows. Let's say I have this array, for instance, right? The first thing I will search for is the longest array sorted ending at this position, ending at the end of my array. For instance, if I'm with this example, the longest array that will have sorted ending at the end of the array is actually 2, 3, 5. So my right pointer will be at 2. So that is the first thing I'm going to search. And for this one, for instance, the thing I will be searching is the array ending at position 2. Yeah, because this is actually a sorted array, right? So this is the first thing you're searching for the right index, your right index. Your left index will start at 0. And then now one thing is that the right index you are searching actually gives you one possible solution because this is actually a sorted array. So you can initialize your answer to this actually. And then after this, what you will do is that you are going to consider this. If I'm consider adding this to this subarray, where should I move my right pointer? If I want to add this to this subarray, how far should I move my right pointer for this to be able to be added to this? And I can see that this is actually matching. This is actually smaller than this one, so there is nothing to do. I can consider a solution having this and this element. I will actually move again like this. If I want to add this to my subarray, how far should I move this? For this one, nothing. I shouldn't move this because 2 and 2 is not actually increasing, but it is not decreasing, so it's actually a valid solution. I'll go then to this. If I want to add this to my subarray, if I want to consider this as the prefix of my array, how far should I move this? So you do agree with me that if I want to consider this, I should erase this and move here, which will give me one another valid solution, right? And then if I want to choose this, how far should I move this? If you want to take 17, you need to move this one right till here. And by computing this until, if I want to take this guy, it's not possible because if I'm taking this guy is breaking the prefix being sort. So whenever you are moving your left, you need to check that, okay, the prefix is still sort. And whenever you are choosing a valid left end, you need to compute the solution at that position, and if it is smaller than the previous solution you are having, you keep that one. So basically that is the idea. So now to code what we just described, how will it look like? The first thing is to find the right index. So exactly what we just explained, the first thing you are doing is that you are initializing your 2 pointer left and right. Now you are moving your right pointer until to the first element that will keep the rest of the elements short. And if that first element that you found is actually the beginning of the array, that means -1. That means there's nothing you need to remove in order to have your array being sort, so you return 0. Otherwise, you move right plus plus, because the element that you found is actually the element which is breaking. So it's the next element that is the valid solution. And one possible solution is actually the solution that will move the subarray from the beginning to the right. So that's why removing element from the beginning to the right is a possible solution. You initialize your answer at this guy. And now in this logic, what you're doing is that for each of the element, you want to make sure that you are moving the right pointer till the element that will help you to consider the prefix ending at left. And for that, you need to check the right element, which is actually greater or equal to left. That is why if it's actually less than left, you keep incrementing. And for each of the solution that you're finding, you compute the minimum, like you compute the number of elements that you need to remove, and then you make sure that that value is computed with the previous answer and only the minimum is kept. And for each of the step you're moving forward, if the next left is actually breaking the left, your prefix array sortability, if I want to say it that way. So if you are moving to an element that is making the prefix not sort anymore, you need to break. I mean, there's nothing to do, and there's nothing else to do, and otherwise you return your answer. So let us submit and see what it gives. Yeah, performing pretty well. So this was my approach of solving this. I hope you enjoyed. Feel free to give me any input. I'll be really happy to interact with you regarding this. See you tomorrow for a new problem. Ciao.